All right, my growth mindset, math side, maniac, Panthers, rah! Just keep your headset on there, Mr. Hoffman. All right, so what is a rational number? Part one. So far, we have come to this conclusion that whole numbers and their opposites, whatever the opposites of whole numbers are rational numbers. This includes zero. That's where we left off. Let's keep going with this lesson. Get what you need, like Liberty Mutual, right? You only pay for what you need here at Liberty Panther Mutual. It's mutual. Why won't you change? There we go. Come on. There we go. Oh, now I'm doing all kinds of crazy things. I guess I never stopped doing kinds of crazy things. So we described and defined a rational number to the first part one, which we said just a moment ago, whole numbers and their opposites are rational numbers. And integers, we also said whole numbers and opposites are integers. They're integers. So we're also saying that integers are rational numbers. Let's just quickly look right here. Oh, you keep coming up. Just go away there, will you? Get out of my way, will you? X, it marks the spot usually. There you go. So we're saying that everything in green, see all this yellow stuff, those are whole numbers. All this blue stuff, those are the opposites of those whole numbers, including zero as its own opposite. And we're saying everything in green are integers. So whole numbers and opposites, all the yellow and blue, are inside the green here. So these are all integers. Okay, yeah. Oh, and just origin, that's a nice thing to know. That's zero is the origin. So let's keep going. Next part of our lesson, identify positive and negative numbers on a number line. State the coordinate. Coordinate. Oh, we should talk about what a coordinate is. We'll get more into that. I don't know how I missed that. It's just a place. It's a point on a number line. For example, 2, -2, that's a coordinate. Oh, look, there's a coordinate. It's a location, basically location of a number on the number line. Location, that's the coordinate. So the coordinate here, -2. What's a coordinate of 5 and 3? Can you spot them? Oh, those ones you've done before, right? So 5 here, 3 here. Those are coordinates. Yeah, okay. Find the missing number. See if you can spot it before I do. What about A? What'd you get? Maybe it's easier to do B first? I don't know. See, what's between -1 and 2? This is weird. Well, I know what comes before 2 is 1. And I know what comes before 1 is 0. Aha! Oh, -2, -1, 0, 1, 2, 3, and then 4. Ta-da! Oh, what the heck? So I'm kind of looking, before I even go to do any of these, see, I'm like, well, I mean, I could look between 8, -8, -12. There's a lot of numbers. But if I just kind of go like this, from 12 to -14, that's 2. We're kind of going 2 spaces backwards, so -2, right? 14 to 16, another 2 spaces, -2 again. So 12 minus 2 is -14, 14 minus 2 is -16, 16 minus 2. There's the pattern. So let's go way over here and start with -2. -2 minus 2 is -4. -4 minus 2 is -6. We're just saying, oh, look, 2, 4, 6, 8. Who do we appreciate? Mr. Hoffman. Well, if you don't, at least you could say, my mom. Not my mom, but like your mom. You get the idea. I don't mean to say your mama or anything. Okay, where were we? 2, 4, 6, 8, 10. But it's a negative. All right. See? Do 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 do. Am I trying to draw Elvis, maybe? I love it, I love it. Oh, yeah. Oh, that's a Frankenstein Elvis. Okay, next. Find the missing numbers. Oh, I know. Look, 8, 6, 4. Going backwards. -2, -2, -2. -2 is 2. What's 2 minus 2? 0. What's 0 minus 2? -2. What's -2 minus 2? -2 is -4. Interesting. There they are. I'm not sure who I'm drawing this time. I like drawing big heads with a little body. Make a little nose. Some kind of weird animal person mix combination with one eye kind of being in a weird place. Okay, next. Okay, let's do this one together. -3. Ooh, what? -8. Oh my gosh. Well, there's -15. So I know negative 14's got to be right next to it, right? Negative 14. So we can say this is here. Negative 3 is going to be really close to 0. So I'm just going to do the bunny hop. I'm going to start on 0. I'm going to go hop 1. That's negative 1. Hop 2, negative 2. Hop 3, negative 3. There you are, negative 3, right there. Oh, negative 14. We did that one. Oh, negative 8. Negative 8. So what if do we have to go back to 0? We could. But, you know, we go 1, 2, 3 negatives, 4 negatives, 5 negatives, 6 negatives, 7 negatives, 8 negatives. Negative 8 would be right here. And what color? Yellow. Yep, as you were to fill all these in, we don't have to do that. So this is negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. They all fall right into place. Select the locations, negative 2, negative 11, negative 17. This is kind of redundant, so let's just go. Solve word problems. The temperature is 5 degrees. And if you think of a temperature, usually like up and down like this, thermometer, you got like maybe 0. And then you have things that are called below 0. That's really cold. You probably never have that around here because I have, where I'm from, Ohio, Cleveland, Ohio. We've had some negative 5s, negative 6 one time, but negative 3, negative 4 usually is the lowest it goes with the wind chill though. Ooh, man. So these are the negatives, like negative 1, negative 2, negative 3. Everything else is above 0, above 0, plus 1, plus 2, plus 3. So we're talking about just 5 degrees. So that would be right up here somewhere, plus 5. So that would be plus 5. But if you're talking below 0, uh-oh, here's 0. We're talking 1 degree below 0. Well, that'd be Celsius. So if we're using, yeah, this is the Celsius side here. Normally we talk Fahrenheit. What 0 degrees Celsius is the same as 30 our Fahrenheit. So that's cold. 0 degrees is cold. That's like freezing. It's actually 32 to be exact, 32 point something. But anyhow, the important thing is we're talking 1 degree Celsius. That's going to be on the pink side here, below that 0. So that's going to be a negative. See how these are negatives? I kind of crossed it off sort of negative numbers. So that's negative. Below is negative. Above, or we don't say above, like this one here, we didn't say above, but it's assumed to be above if we don't say above when you talk about temperatures. Temperature, oh look, there it is, below, right away. That's going to be right about, and that's Celsius, right around here somewhere. So that's a negative number, negative 21. Removing. If you're removing pictures, right? See, you got some pictures here, and you remove them. You're subtracting, you're taking away. That's going to be a negative 3. We just removed 3 of them. You found crayons to add. Plus 2. This is almost so easy. I don't know why we're doing it. Johnny is swimming at 1 meter below sea level. He's below. See, here's above. Here's below. Here's the water. Oh, put a nice little blue for water, from wavy water. And Johnny, let's see, Johnny, he's swimming 1 meter below. So this will be 1 meter. Here's Johnny right here, right? He's swimming, he's got little goggles on, and then he doesn't know it, but right behind Johnny is one of these things. I'm not doing a very best job of drawing this thing. It doesn't look like a shark, does it? It's supposed to be a shark. Gosh. Baby shark do 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 do. Baby shark do 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 do. Baby is flying. He's in trouble. Johnny's like moving 1 mile per hour. Shark is moving 10 miles per hour. What's going to happen? Okay. Sorry, no one's going to go swimming ever again now after that incredibly graphic drawing that Mr. Hoffman just drew of sharks chasing somebody. Okay, write an integer. Integer that represents the scenario, 3 feet below 0. Below. See, this is a little cheat sheet. Below is negative. So if you need a cheat sheet, you can kind of use it. let's see, the value of a cart decreased by 1,000. So where's decrease? Oh, there it is. That's also negative. So it'd be negative 1,000. If you need it, there's a little cheat sheet. Loss, empty, and drop. Up, increase, above, gain, filling, rise. Gain's a good one. Smells good too. Gain smells really good. Yeah. Ah, there it is. Okay. Integer that represents the scenario. 52 grams decrease in mass. Do you see decrease over here? Do you see what I'm trying? You can't see it now. I just crossed it off. How about now? Do you see it? Open your eyes. I'm blind in this side pretty much. And that's a true story, but we'll talk about that some other time. Okay, where were we? Okay, next one. Basketball team scored 20 more points this week in the game compared to last week's game. What integer represents a game? So we got more and gain. So where do you see more? I don't see more, but more should be up there. Let's put more in here. More, because more is more. Well, sometimes less is more, but if less is more, imagine how much more it would be. Okay, don't get too much into that. Don't read too much into that. But anyway, gain. There it is. Gain is a positive. So this would be a plus 20. Yeah. Oh, look, I made this little cheat sheet too. That's interesting. So they kind of go together. Up, down, up, down, up, down. How's it go? All I do is win, 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 no matter what. All the hands go up, down, up, down, up, down. Put your hands in the air and make them stay there. Okay, increase, decrease, above, above sea level, below sea level. Gain, loss. Your gain is my loss. No, your loss is my gain. No, can't we just have a gain, gain? Can it be a win-win? Let's try to do a win-win. Filling and emptying. Yes, rise and drop. Rise in temperature, drop in temperature. Ascend, go up, ascend the mountain. Descend means go down the mountain, or back down the mountain, down. Yes. You know you're going to get English language arts vocabulary lesson in math, did ya? Sometimes you got to know your vocabulary. We did this one already. What's that? That's a repeat, I think. Is that a repeat? That's a repeat. Okay, a rosebush grew for, I'm not even go there. Let's just, you know what? Oh, there's the answer anyway. We don't have time for this. We got more of a lesson to do. Represent rational numbers. We've been represent rational numbers, but what we were doing is integers. We've been doing these positive and negative numbers. That's what we've been working on so far is integers, which is really, to be more correct, it's not just negative numbers. It is positive negative numbers, but also the number 0 is missing from here. 0, which is not positive or negative, but it is a whole number, which is an integer, yeah, and it's also its own opposite. So anyway, okay, let's go. So what's a rational number? As we were just saying, and we said before, whole numbers and their opposites are rational numbers. Whole numbers are essentially the positive numbers for the most part. We can say, think of them as positive numbers. Opposites are basically negative numbers. But again, this little 0 kind of spoils that, so we can't necessarily do that because 0 is not positive and 0 is not negative. It's one happy neutral number. Try to make it a happy number here. He's a really happy number. 0 is my hero. You know, we could put a cape on 0 and check 0 out. Yeah. 0, the hero. Okay, and we'll put a little S here, even though he's not superhero. Well, he's kind of superhero. The triangle. Next, rational number part 2. What are all these numbers in between this blue numbers here? I should use blue. I'm going to stop shoulding. No more shoulding. I'm going to use a blue. So blue, 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 blue. Hut, hut. 41, 42, hut, hut. Blue, blue, hike. So these numbers, no, go take a hike, Mr. Hoffman. No, that's not nice. These numbers here in between, what are they called? The blue numbers. The blue numbers are called integers, right? We've got that. But the numbers in between, like these things right here, these ones, those are called, you know it as fraction. Fraction. But notice these are fractions that cannot be expressed as integers. For example, like 1/2. 1/2 cannot be expressed as an integer. You know, but what if it were 2/1? Yes, because that's 2, and 2 is an integer. What if it were, let's try 12/3. Guess what? 12/3 is the same thing as 4. Yeah, because it's 12 divided by 3. Yeah, so That's also an integer. So the ones that cannot be, anyway, let's not get too much into that. Next, as we wait for the hourglass. There it is. So what are all these, what about these ones? Oh, I already went to it. Spoiler alert, mixed numbers. So, and again, the caveat here, the caveat means like, with the exception of, I got to tell you something about this. That's my fancy way of saying, but you got to understand this though. You know, there's something attached to this, my caveat. All right, my caveat is the following. These are mixed numbers, and let's get me out of the way. There you go. That cannot be expressed as integers, same as before. Yeah, maybe we'll just leave me there for now. Next. So what is another way we could represent fractions and mixed numbers? There's that, right? And here's a clue. This thing's taking its time. These thingies. What are these thingies here called? Yeah, all these little red thingies. We can write them as fractions, or we can write them like this. What form is this? Fraction form? And I know you just can't. You're screaming at me already what the answer is. Okay, fine, here. These thingies are called decimals. But here's the catch. In order to be rational numbers, and considered in these categories. I think I just gave away a future event. But anyway, these are decimals that can be expressed as a fraction. We can write this as a fraction. 0.25 as a fraction is the same as 1/4. Right? 0.5 is 1/2. 0.75 is 3/4. We can write these as fractions. And so on. 1.25 is 1, it's mixed numbers. 1 and 1/4, I guess, but it could also be written as a fraction, which is 5/4. Right? 5/4 is the same as 1/4. This would be 1.5, would be 1.5, or it could also be 3/2. All right, we can write these as fractions. All right, so where was Mr. Hoffman going with this? Here's where I'm going with this. Some decimals cannot be expressed as a fraction, all right? And they can't even be expressed as decimals, really. I mean, they sort of can. Do you know what I'm talking about? There's one very famous or infamous, this is just fun. Let's just move myself around here just for fun. And this will give you a hint. See, I'm going around in a circle. I'm moving around in a circle. Can you see me? This is your hint. Okay, there is a very famous or infamous number, I guess. It's considered a number. Yeah, I think it's a number for sure. It's a special kind of number, and it's not rational. It's an irrational number. The most famous irrational number ever. Yep. And cannot really write it as a decimal. You sort of can, but you definitely can't really write it as a fraction unless you're trying to estimate, and it still doesn't, it's not the same. What am I talking about? You got it? You got it? You got it? We celebrate it once a year. Some people celebrate it more than once a year, but every one day a year we make a special day for this particular thing. Yeah, I think you know what it is now, don't you? It's pie, and it's spelled P-I, not P-I-E. Although P-I-E tastes yummy, P-I might not taste as yummy. It all depends. So we often know it as 3.14. We abbreviate that. I mean, some serious abbreviation. That means we shorten it very short, but it's a lot longer than that. How far does it go? Do you know the next two? Oh, I was going to say, do you know the next two digits? One way to easily remember them is 14 and then 15, right? So now you know the different 3.1415. You should know, everyone should know the first four digits, decimal digits for pi. 3 is the whole number, the whole digit. Then you got 0.1415. See, 1415, 14, 15. What about the rest? Oh, now it gets kind of crazy. There's really no pattern to this, 3.1415. How are you going to remember 92? Unless you were born in 1992? Or do you know anybody born in 1992? I don't know how you're going to remember 92. I don't know how to remember 92. 92, I had already graduated by then for a couple of years, so I don't know. And then a 6. Oh, does it go more? Oh, look at that. And it goes on and on and on, and it goes on forever. And if you look down here, because forever, like to infinity and beyond, and this is like seriously infinitesimal, because infinity I think is usually we use for bigger. Infinitesimal means small. It goes to infinitesimal and beyond. That's not even correct language, but proper usage. But still, the idea is it just goes on and on and on and on and on. Because this is the tenth digit, the hundredths, the 10 hundred, no, the wait, thousandths, 10,000ths, something like that, 100,000ths. And can you imagine what these digits are down here? I have no idea. Oh, here's a fun little way. Check this out. Oh, I got to get out of your way so you can see what this little cartoon says. Oh God, when will it end? It's a PI eating contest. Remember I talked about eating pot? Okay. All right, let's go. Why did all of the other numbers avoid conversing, having a conversation, talking to, with PI at the party? Pi at the party. Well, this is why. It all started in third grade, and because he goes on and on forever. Oh, poor number 8. By the way, do you know this one? What did the 0 say to the 8? Don't look it up. Ready? Nice belt. Okay, now you can look it up, see if it doesn't make sense to you. Oh, here we go. Back to this. So what do we got so far? Kind of a quick review here. What we're trying to say is that integers include whole numbers and opposites are their whole numbers. But there's these other numbers in between the integers, right? Some of them, some of them go on forever. Those are irrational. Pi is irrational. We're not talking about pi. Although some of the numbers can go on forever and still be rational. That's another story. The point is, can you write it as a fraction? That's the real deal. Pi, we cannot really write as a fraction. No, can't do it. So non-integer fractions, mixed numbers, and decimals. We color code those all the purple numbers. And then the integers. Now, put them all together, you got rational numbers. Those are all the rational numbers. Remember, not pi though. Pi is not rational. But these are all rational numbers because they can be expressed as fractions. Also ratios, but ratios don't get too much into that. We'll learn about ratios later. That's where rational comes from, ratio. But think of it as more of a fraction for now. So non-integers, so part 2 is, okay, first of all, part 1, whole numbers and their opposites are rational numbers. Also the non-integer fractions, the mixed numbers and decimals that can be expressed as fractions are rational numbers. Okay, as long as we can write it as a fraction. Not that pi though. Pi you can't write as a fraction. Okay. So normally we'd come in here and try to write some examples, but we've already just went over tons of examples. And if you look here, here's a bunch of examples of rational numbers. They could be made by, another way to put it is dividing integers. One integer divided by another integer makes a rational number. So location, 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 the most important things in business. And apparently in math sometimes. So what's the location of 8/3? And then, look at this one, a negative 11/3. So, we got to break these down into thirds before we can really get into this. Once you break things down into thirds, then it's going to be a lot easier. And luckily, they give us the 0 here. So, and they kind of give us these bigger ones, these bigger marks. See the bigger marks here? These hash marks here? These are the bigger ones, right? So we know that's significant. We're going to look out for that to mean something. And I can already see that they divided the 0 to the 5 here, that I can see that this is probably going to be 4, 3, 2, and this is going to be 1. So, okay, this one's going to be -1, -2, -3, -4. All right. Now we can break it down into its thirds because they kind of already did that for us. If you look at it carefully, let's use a green, not green, nice blue. So how many thirds do we have here? Here we have 0 thirds. Here we have 1/3, 2/3. Oh, and here's 3/3, 4/3, 5/3. 2 is 6/3. And we need to get to 8/3. Where would 8/3 be? I'm going to let you find it. I'm not doing any more of this problem. You find 8/3. Let's go to -11. -11/3. Where would that be? So let's go the other way. This is still 0/3. So this is still 0/3. But here we're going to go. Let's make that green a titch thicker. Sounds funny, titch thicker. So this is be negative 1/3, negative 2/3. This is going to be negative 3/3. And you just keep going until you get to negative 11/3. This is going to be negative 4/3, negative 5/3, negative 6/3, negative 7/3, negative 8/3. I'm not doing any more. You figure it out. I'll do one more. I'm lying. I'm going to do one more. This is negative 9/3. Yeah. Okay. Next. Location. Ooh, 5 and 2/3 and 5 and 1/3. Oh, that's interesting. Oh, look, they give us the 0. If they don't give you the 0, how would you know? I mean, that's pretty tough. Well, you'd have to just count, right? I mean, 6, got negative 6 here, positive 6 here. I guess you just count these things until you get to where the 0 is, right? Like if you started, let's start a positive 6. Let's just count back here. I'm going to highlight them first so I don't get lost. If you didn't have a 0 there, because sometimes they're not going to have a 0, you just go, oh, that's going to be 5, 4, 3, 2, 1, and then you would know that the 0 goes here. Negative 1, negative 2, negative 3, negative 4, negative 5. So negative, see, 5 and 1/3. Well, here's 5, and here's 5 and 1/3. This would, just in case you're wondering, this would be 5 and 2/3. This could be 5 and 3/3, which is the same thing as 6. 5 plus 3/3, which is really a fancy way of writing 1, special kind of 1 equals 6. Okay, next. Select the locations on the number line. Oh, 10 halves and 9 halves. So again, luckily they put the 0 in for us, but if they don't, you know how to find it now. You just kind of count your hash marks, the big ones, till you get there. So, let's put the numbers we know. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. So let's do 10 halves. Okay, this is 0 halves. This is, oops, this was 0 halves. Let's fix that. 0 halves, 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. Oops, jumping ahead of myself. Thinking one thing and writing another. Okay, you get to find that way. And then just go the other way. Let's go negative. Let's see, negative 9 halves. This is negative 1 half, negative 2 halves, negative 3 halves, negative 4 halves, negative 5 halves, negative 6 halves. Am I doing this right? Yeah, I think so. And so on until you get to 9 halves. You can do it. I'm not doing everything for you. Come on. I think I am. Identify the locations of the points plotted on the number line below. Write your points as improper. They want you to write them as improper fractions. So this one right here. Oh, good. They give us the 0 again. How nice. What are they breaking it down into? So again, I'm going to go to these bigger ones so I can try to figure out what each interval, what value is to each of these bigger intervals, right? So I can kind of say, oh, 1, 2, 3, 4, 5. That's 5 parts. So these, each of these have to be worth 1. So I'm going to count by ones. 1, 2, 3, 4, 5. Okay, let's clean up that up a little bit. And you can see that's each one represents 1, so we can work backwards. Negative 1, negative 2, negative 3, negative 4, negative 5. So we know that this has got to be right here. It's in between negative 3 and negative 4. So it's a negative 3.5 or negative 3.5. But they want improper fractions. How do you write it as improper fraction? Well, let's see. You can do 2 times 3 plus, we're going to break it down in half. Basically, let's just back up for just a moment here. 3.5, 3 negative 3.5 here, negative 3.5. All right, I'm going to write the negative 3 like this. It's like 3 pieces of pizza, or 3 whole pizzas, really. Because, okay, then we're going to represent that with the pink. Meow, this 3 is the pink. We'll put that negative sign back on in a few moments. This half is going to be not pink. We're going to switch that over to yellow. And then, so I'm going to draw another pizza. But this time it's only going to be half of a pizza. So I'm going to just fill half of it. So 3.5. Basically, how many halves is that? That's going to give us. How many halves do we have? So 3.5. Well, if we got to cut them all into halves. So let's cut this pizza in half, cut this pizza in half, cut this pizza in half. So this 3 right here, how many halves do we have? 2, 4, 6. Okay, 2, 4, 6. So that's first, we're going to have six halves, right? Then we have one more half, the yellow. So let's just color code this. So 6 halves is the pink, and then add the yellow. Add the yellow, which is 1 half. That gives us 7 halves. And that is why our little method that we use works. Really, our method could be 2 times 3. Oops, I'm going to turn off my notices for a couple of moments here. So I can do my recording without interruptions. Mr. Hoffman, maybe next time you will think of that ahead of time. I might. I just might. Do not disturb. There we go. Where were we? 7 halves. 2 times 3 is 6. 2 times 3 is 6. So we just multiply this 2 that I did in green by this 3 in green, and we get 6. That's where this 6 comes from, right? Then we add the 1 half. That's where this 1 comes from. So 6 plus 1, that gives us our 7, and the bottom number just stays 2. All right, this 2 stays as a 2. Okay. We didn't finish though, did we? So that's 7 halves. That's what you would put in for this one. So what's the next one right here? This is between 4 and 5. So this is 4.5. You know what? Let's just duplicate this and clean up the mess. Mr. Hoffman's got to learn how to pick up his toys. Put your toys away. Don't delay. Help your students have a happy day. Oh, yeah. There. Oh, that's much better, right? Okay. So this is 4.5. Also, we can call it 4.5. So let's turn 4.5. Now, again, the bottom number here in the fraction tells you what we're going to break it down into. Halves. How many halves is that? So put the 2 here. How many halves is 4.5? We already got 1 half here. What about 4? How many halves is that? 1, 2, 3, 4. 1, 2, 2, 2. There's 1, 2, 1, 2, 1, 2, 1, 2. That's 2, 4, 6, 8. That's where we get the 2 times 4 is 8. Now, plus we have this other half, one more half. That makes 9 halves. Oh, interesting. 9 halves. So 4.5 is really the same thing as 9 halves. 4 times 2 is 8, plus 1 is 9. And of course, we're breaking them down into halves, so this 2 stays a 2. Next. I might just let you do this one on your own, except you don't go figure out where's that 0 going to go. Let's do our little highlight trick. Highlight the big ones. The big hashtags, figure out what these intervals are first. It's pretty basic at this point, right? If it's 7, that's 3. We could pretty much guess. We're counting by, probably counting by ones. So this would be -2, -1. Probably 0 is going to go here. All right, let's see if that works. 1, 2, 3, 4, 5, 6, 7. It does work. So now these are going to be halves. 1 half, 0 halves, right? -1 half. Oh, -1 half. Sorry. This would be what would this be? -2. -2 halves? Yeah. -2 halves. -3 halves, and so on. All right, you figure it out. Just go this way one more time. 2 over 2, 2 halves. 3 halves. 4 halves. Okay. Are we done yet? Oh my gosh, this lesson goes on forever. I'm not doing it anymore. You're on your own. We do Excel, but more importantly, there are far better things ahead than we have left behind. I don't know. I've left behind some really good things though. But I love C.S. Lewis. I'm not going to lie about that. All right, and here is some anchor charts for your dining and dancing pleasures. Here's one to help you out with some things perhaps. And here's another anchor chart for your dining and dancing pleasures to help you out with things. Perhaps. It's got some nice little things down here. Depositing money in the bank, scoring points, going up in the stairs, gaining under owe money when you owe somebody is a negative. Overdrawn bank account. Ooh, that's a negative. Don't do that. Don't recommend it. Oh my gosh, this is a long lesson recording. Okay, see ya. Bye.